From consumer electronics to industrial IoT devices to smart vehicles, from digital twins to smart metering to predictive maintenance and a host of other business-critical use cases. What these devices and application scenarios have in common is the network's edge and an ever-growing need to move data in a friction-free manner from the edge to the cloud and back. And that's not easy given the tangle of technologies involved. New network protocols are emerging: 5G LTE, Cat-M, NB-IoT, mobile and IoT gateways are evolving, the cloud itself is always in flux. Edge innovation begins and ends with you, the developer. You need solutions that enable you to drive interaction effectively between edge applications and accelerate the delivery of application updates as new capabilities are introduced. Given capped team sizes and a chronic shortage of resources with skills in specific areas, such as security, networking, and data management, that already seems like a tall order. But in reality, it's even taller. Edge data management sits at the top of the list of capability gaps for developers. There's a maturity curve when it comes to edge data management, and many developers are still designing applications with older paradigms in mind. Those paradigms are only going to prevent you from developing the solutions that you know you need to build going forward. So where are you and your development team on the edge data management maturity curve? Historically, developers working at the edge worked with flat files rather than a real database. An actual database was overkill for early applications. In fact, they were too big to be embedded in a mobile app or an IoT device. They were also expensive and complicated to maintain. A flat file, though, managed via simple file I/O API calls sufficed. And it was inexpensive. Over time, many developers used these API calls to build additional incremental services into their applications, often replicating, though in non-standard and developmentally time-consuming ways, functionality that was already built into existing database products. As that became apparent, developers began to move on to the next stage of the edge data management maturity curve. Instead of continuing to recreate functionality already present in a real database product, developers began to build solutions with a new database that had emerged on the scene: SQLite. Compared to one of the behemoths from Oracle or Microsoft, SQLite is a bare-bones database that is serverless only. SQLite was free and it delivered better functionality than a flat file. In the early days of mobile applications and edge devices, this underpowered client did what it needed to do, until it didn't. Networks expanded, scenarios arose in which developers wanted devices to share data, gateways and remote branches emerged to provide additional compute power and analytics at the edge. It was possible to move data from SQLite to a more powerful database running on an edge server, but doing so involves additional operations to extract data from SQLite, transform it into a format suitable to the target database, and then load it into the actual target database. And there were many of those, each with their own architectural advantages and limitations. Some touted for superior JSON support, which might be ideal for document stores. Others touted better support for streaming data in time series format. Still others handled back-end reporting, out-of-order transactions, and other requirements. The world was evolving quickly at the edge, and it was becoming a fit-for-purpose, best-of-breed sprawl involving many different types of databases and an even larger number of ETL processes and procurement costs, integration costs, and security risks required to enable interaction with the spindly-legged SQLite. That's the tipping point at which many developers find themselves today. What's needed is a comprehensive edge data management platform with a single architecture bridging all the data management layers that have evolved from the device to the edge to the enterprise and/or the cloud. And that's what Actian Zen does. At its core, Actian Zen is a simple, secure, scalable, and stable platform for ecosystem-wide data management. It is built around a key value store engine capable of storing any data type, including structured data, JSON, and blob. It is ideal for persistent data sharing and is embeddable in application processes and microservices. Because Zen supports programmatic interaction through a well-documented Btrieve interface, it's extremely fast and takes direct advantage of enhancements in underlying hardware and software technologies, including successive generations of processors, operating systems, hypervisors, and container technologies. Support for both NoSQL and SQL enables Actian Zen to support the best of both worlds. The NoSQL API has direct KVS engine access and is blazing fast. It can handle schemaless, multi-data operations, and interacting with the API will feel familiar to any developer accustomed to working directly with a file management system. In addition to the NoSQL API, Zen also offers a fully ACID-compliant, ANSI standard SQL overlay with powerful query and reporting capabilities. Developers can easily use one or both options to interact with the same data table. What does all this mean for modern edge data management? Increasingly, intelligent edge applications collect time series data from downstream sensors, the camera in a cell phone, for example, but they also transfer data to and from the cloud to support decision-making at the edge. For example, grant access to this device based on facial recognition against this account or for access to this particular app. Or automatically order this part to be routed to this service repairman for installation on this route next Tuesday. And here's the thing about these kinds of edge interactions. NoSQL provides better support for the time series data collection on the front end, but SQL provides better support for the queries and transactional responses on the back end. Actian Zen provides you with both non-SQL and SQL modalities on top of the KVS engine. As a platform, Zen provides you with a single architecture that is modular and scalable. There's a serverless edition, Zen Core, with a footprint of around 5 megabytes in storage, yet capable of handling individual data tables as large as 64 terabytes in size. It can be embedded in most programming and scripting languages, including C, C++, C#, and Python. There's a server edition, Zen Edge, that provides full client-server capabilities and requires less than 50 megabytes of storage space. It can be bundled with an application, but if you separate it from the app, you can interact with it using any of the features on the OS, hypervisor, or container network, such as security and other administration features that you might use in connection with any other application or process running in that environment. Finally, there are the Zen Enterprise and Zen Cloud editions. These require an additional 150 megabytes of space, but they provide a full-blown application experience with a GUI interface to the database, including a built-in SQL editor along with options for built-in replication, backup, and auditing services. Zen Core can run anywhere, but it has been designed with mobile and IoT scenarios in mind, particularly those involving smartphones, IoT devices, gateways, and mid-range instrumentation. It has been tested and certified with supporting tools for Android, iOS, and embedded Linux platforms. Zen Edge has been designed as a server supporting hundreds or thousands of downrange IoT devices or embedded Zen Core databases. It is intended for use in IoT and mobile network gateways and in support of larger, more complex instrumentation subsystems, such as those found in autonomous vehicles. Zen Edge runs on embedded Linux and Windows IoT core platforms. Zen Enterprise and Zen Cloud are identical in terms of functionality, but intended for deployment in distinct environments. Zen Enterprise runs on laptops and desktops, as well as ruggedized and commercial servers running Mac OS, Windows Server, and popular variants of Linux. Zen Cloud runs in Docker containers with Kubernetes management and hypervisors from VMware, Nutanix, and Microsoft. It can also be installed on VMs in public and private cloud deployments. Because Zen runs in environments extending from small IoT devices to smartphones, laptops, and desktops, as well as small, medium, and large servers, both on-prem and in the cloud, it provides systems designers and interrogators with a seamless data management platform that can connect edge devices anywhere, from a factory floor to instruments in an autonomous vehicle, from an app on a smartphone to a point-of-sale device and onto an ERP application supporting a dentist's office, a construction site, an oil rig, or whatever. All editions of Zen offer the same SQL capabilities, use the same NoSQL API, and support the same data file format with AES 256-bit encryption. There's no need to transform data between any edition of Actian Zen, whether it's moving from an edge device to an on-premise laptop or up to the cloud. This improves data transfer speeds and security while eliminating the cost and time previously required when you were at that earlier stage of edge data management maturity to manage integration efforts centered on data management. This single architecture consistency of Actian Zen offers clear advantages to developers focused on building and scaling applications. But there's another benefit enabled by architectural consistency that is just as important. Zen enables your data management and analytics tools to operate consistently throughout your operational ecosystem, from the furthest edge to deep within the cloud. With Zen, developers can use the tools, programming, and scripting languages they are accustomed to using to upgrade their data management capabilities without having to become database experts or having to rely on DBAs. You can embed data analytics capabilities on edge devices to work with persistent local data. You can remove noise from time series data at the local level, assess and act in real time on event-driven changes at the point of collection. You can interact with the cloud when necessary, but only if there is need to do so. You can dramatically reduce latency by performing so many operations locally, and you can also avoid service provider fees arising from the movement of data to and from the cloud. And the insights that can be drawn from such a consistent architecture? Data engineers and scientists can easily access real-world edge data in batch or streaming modes to develop and tune machine learning algorithms and securely deploy unsupervised ML routines at the edge. You can use Spark and Kafka streaming data and IoT networking protocols via JDBC to transfer data to and from Zen. Unlike proprietary operational hardware and software tools, such as proprietary historians, Actian Zen is built on a foundation of industry-standard IT protocols and interfaces. This makes it easy for developers to interact with ERP applications and native SaaS applications through protocols such as JDBC and ODBC, or to make calls to Windows apps using .NET APIs. You can readily connect back-end ERP systems to front-end mobile workforce applications, for example, and facilitate the extraction of critical IoT data to further automate processes or provide decision support for field personnel. Ultimately, the complexities of modern edge data management are with us whether we like it or not. Actian Zen provides a path that can bring developers to the next level of operational maturity. By providing developers with a data management platform that is consistent from the edge to the cloud, that enables the creation of more intelligent distributed applications, that enables a more rapid reaction to opportunities and challenges throughout the ecosystem, and that accelerates real-time decision-making throughout the enterprise, Actian Zen can help you deliver improved outcomes like no other edge data management solution. For more on how Actian Zen can make your entire technical team work smarter and deliver more, visit our website.